So thanks for coming back after the break. I was reminded in the last session, this Internet of Things. I walked into the phone store the other day and asked them for a battery for my phone. And he said, well, that's only worth about a AA. So I lost that deal. I'm going to take a bit of time and talk with you about the competition that we've been hosting for a number of years, a new instance of that, which we call GT Journey. Early on, we had a competition where students would compete with industry sponsorship to create apps based on their own desires around a theme that industry would put together. I sponsored a category early on called the Campus Community category, and students would build things that would be useful to them in their endeavors as a student. We've turned that now into a yearly competition. We had our second year's judging last night. This is the GT Journey portion of the Convergence Innovation Competition. And I'm going to talk with you about the winners after I show the video. I hope so. Yes. So we'll see how this runs.
Barcode Fitness allows you to easily record the exercises that you complete using your mobile phone.
Witness is a mobile application that lets students quickly indicate when they've fallen behind.
Our goal is to minimize the amount of time and worry students put into traveling between their appointments.
It's always fun to see what folks come up with. We've got some of the winners from last night here. First, I want to take some time to thank some folks. The competition is run out of an organization that we call the RNOC. It used to stand for Research Network Operations Center, but now it just doesn't mean anything. It's just the RNOC. So what can I say? It's a name that's stuck. You say, well, let's change the name, but when you have so much stationery printed out, you can't change the name. So we're leaving it where it is. The lab staff, is there anyone here from the RNOC lab staff today? They're all at home asleep. Yeah, got to have a few folks here. These folks are Georgia Tech students that work really hard and put in a lot of time to help us manage the categories, work with the students, work with the platform for doing the development, help the students in any way that they are needed, and just really make this work. We have some of our full-time staffers who have been doing this, came up with the ideas. I see Matt Sanders is here. Is Russ still here? Russ is there too. These are the guys that basically pull this off every year. And Shiva is, in the last year or so, been here making this work as well, so thanks to all of you. I know there's people I'm leaving out, but I just want to take a few minutes for that. A lot of campus partners. One of the ways that we work this competition is through making data available to the students. That data can only be made available to the students if it's made available on the campus. I'm a firm believer that data is an asset, a major asset, as I think Willard said on the panel here before. We need to take care of our data, but more than that, we need to curate it. We need to make sure it's available, make sure that it's clean, and make sure that we can use it. So that's one of the things that the staff helps to do as well, working with our partners. Our facilities group, as an example, this past year opened up their electrical usage data and gas usage data for the campus to students to use. And these are the only ways that we can do some of these things is through that partnership. So I thank all of the folks who have worked there. This year we had over 100 students that participated in this. which is an amazing thing for me, 100 students in one concerted effort. We had 24 entries. The folks came from 5 different colleges. We had 3 different categories. We had campus and community. We had classroom and academics. We had Forever GT. And so let me just give you a bit of words here. The campus and community are projects that assist people in and around the campus and larger community. Second place was Knockout Fitness. These folks are here. Would you guys stand up? Thank you. All the winners. Why don't we do this? If all of the winners who are here would just go ahead and stand up and just stay standing for just a minute while I read through some of this stuff. Let people see who you are. They can come around and talk to you later on, but just would everybody just stand up who's the winner from the competition last night? These are folks that have done phenomenal work. I really appreciate all that you guys have done. So Knockout Fitness was a tie with Barcode Fitness was another second place winner. On Time GT, the bus tracking, was another one. Who's these guys here? The first place is On Time, like I said. Oops, too many fingers on the mouse pad. Under the classroom and academics, the second place was BuzzNote. Over here, thank you. And first place was Litmus. Are those folks here? Litmus? Okay, they're home sleeping. The Forever GT, second place was Tech Treasures. These folks are here, thank you. And first place was the Facet application. Thank you, folks. Now, I'll let you all sit down. Thanks for bearing with me. I wanted to make sure that you got recognized for the work that you've put in here. You know, it's so fascinating to me to see these projects come to light at the campus, and some of them turn into businesses, some of them turn into companies, some of them turn into other projects and are recycled around. But it's the phenomenal interaction between our students and our folks who run the competition and our leadership team at Georgia Tech that make this a really, really worthwhile project. In the spring, we have another competition called the Spring Convergence Innovation Competition. We have 4 categories that we'll be hosting this spring with different sponsors that I'll come to in a second. We have the Connected Home category covering smart home, personal media, wellness, and families. We have the Connected Transportation category covering mobile and the car, mobile media, mobile logistics, and telematics. We have the Connected Work category, including project management, collaboration, retail engagement, and enterprise transformation, and Connected Communities, so health, IT, education, government, civic computing, humanitarian systems. And the sponsors are engaged throughout the whole period of things. I neglected to mention, and I have to go back, this fall, the fall competition is sponsored by Georgia Tech, our president, under the strategic plan. So Dr. Peterson sponsors this category. So all of you folks who are winners should send Dr. Peterson a note and say thank you for sponsoring this category. In the spring, we have 3 committed sponsors as of today. Code 42, which talks about enhanced cloud collaboration. We have Cisco for personalized mobile experiences. We have GM, connected vehicles. And we have a new sponsor that just happened. AT&T is committed to sponsoring as well. Keep doing that. And we're early. Do we have any questions? Can I take questions from the audience? You see demos. The demos are across the street. Once we get done here this evening, you walk across the street to all the demos, and I think all of you folks are set up to demo your projects across the street. So you'll see all of the winners. All the winners will be there tonight. Starting at 5:30. Yes? So this competition, from my standpoint, is unique at Georgia Tech. This competition has been described as one of the grandfathers of the competitions at Tech. And the way this works, which I think makes it work so well, is Russ Clark teaches a course in the fall semester. And I think it's twice a year, right, Russ? on mobile applications and services. It's a course that's taught which is full, as far as I can tell, every semester with about 100 students. Amazingly, it's 100 students who were in the competition. I don't know how that works, but there's got to be some relationship there somehow. And because of that, the students get access to what, every couple of weeks they turn out a new project, and they learn how to quickly turn these things around. And then after that process, you guys can correct me when I get it wrong, okay? Because you're the ones who did it. So after that, in the spring, we start the competition. The students can individually form teams. They put in for the project, and the lab staff helps them to put their ideas together. We encourage them to do a couple of things. Number one is to be cross-disciplinary, cross different departments on the campus, include a business plan, include market studies to ensure that their project is going to be useful to somebody, and then actually build it. And it's amazing when you tell people they have to build it, it really is sometimes a challenge, but these folks have built these things. They're, in the general case, all of them operate. They're all functioning. There's plenty of additions that they can add to them, but in the general case, they're all functioning. And that's, Russ, did I miss anything there that you want to throw in?
So while the mobile apps class that I teach does tend to bring the most participants, it is open to all students at Georgia Tech, and we do get competitors from across the campus and from multiple classes and multiple types of projects.
Yeah. It's interesting. You might think, okay, the computer science folks would be the majority. Maybe they're the majority, but we've had folks from our sort of Ivan Allen. What is Ivan Allen? It's our sort of liberal arts school, and from
digital media program as well as industrial designers are very active in the space.
Yep.
Electrical engineers, and in the spring you'll see hardware prototypes. We didn't have any this fall for campus, but certainly hardware prototypes make it. But it's a pretty diverse cross section of the population.
other questions. Yes.
I don't have a question, I'll just make a pitch. We sponsored for 3 years in a row, and as a company, we've just seen the creativity of the students and the fact that they have to do not only the technology component, but the business case and the marketing aspect of it. The benefits we've seen come back has been quite useful, and also to just see the creativity of the students, which is, when you get into the corporate world, sometimes the creativity gets stymied a little bit. But I would, depending on who you represent here, I would highly encourage you to talk to Russ and Matt and Ron about the program. It's really, we've seen other competitions around the country and we've not seen anyone like this. And so it's really, we think it's really top notch.
Thanks, Dave. Yes.
Rights to the IP that comes out of
This was a really interesting part of our early process here. In the early days, we wanted the IP to remain with Georgia Tech or with the company. And what we heard back from the students was, well, then I'm not giving you my best idea. I'll give you my second best idea. And so what we have done is make sure that the students own the intellectual property that they're developing here. And they can take it out and produce a company if they would like to, spin it out and do whatever they need to with the intellectual property. And you know what? From that, we all benefit because we get to see these good ideas. They get to put their best effort into it. And the companies that sponsor it get the opportunity to work with these students. In fact, the first year we did the competition, we worked with a sponsor who wanted to award prizes. They put up $100,000 as prizes. And what we found is we spent more time on competition law than we did on running the competition. And so when there's that much money involved, it makes it almost impossible to run a competition. The laws around locking in the teams and no changes and all kinds of stuff that made it just about impossible to run a competition, which is why now the prize is the rights to stand up and say you won, and then some gifts that we give them as tokens of appreciation. But they're not huge monetary amounts that motivate these folks to do this. It's the sheer enjoyment of spending 24 hours a day for about 2 weeks to put your project together. And I continue to be amazed at sometimes it's the simplest idea that comes out of one of these teams that is the most profound and powerful. And I would never have thought of some of these things, but when you're living this environment, you get to see things in ways that you wouldn't have otherwise. And it's a phenomenal gift for me to be able to work with folks that come up with this. Other questions? Other thoughts? Beth, anything I missed?
Is it too late for companies to sponsor for 2014?
It is never too late for companies to sponsor. You can individually sponsor. Your personal foundation can sponsor it. So in the general case, what we do is a company agrees to sponsor a category. You help choose the category. We don't allow just all categories, but you see the general nature of the categories that we have. We found if a company comes in and wants to have, say, I want them to develop this one single idea, we don't get the creativity, we don't get the interest, we don't get the energy around this. So if we have large general categories, then the students can come in and use their creativity to find a way to produce here. We can take partnerships. We do 2 competitions a year. One competition a year is industry sponsored. The one that we just did last night was campus sponsored, but we'd be glad to work with you at any point in the process. There does come a time when it makes it hard for us to work with a company to instantiate their participation in the next competition. So it may be that we would postpone you till the following one, but we'd be glad to work with you. Other thoughts? Matt, Russ, anything I missed? Any of the winners care to say anything? Anybody? You guys are just glad to be done? Yeah. All right, well, let's thank the winners one more time, and then... And then I have the great honor of introducing our next speaker, Jeff Reed from Cisco. Jeff's come talk to us about manageability and SDN, software-defined networking. Jeff leads Cisco's enterprise networking group's investment in manageability and SDN. I'm sure he's going to help us define SDN at some point. He oversees the product strategy, engineering, and go-to-market activities for their SDN applications and infrastructure. Jeff previously was the general manager for Cisco's Unified Access Group, Cisco's largest switching business unit. Jeff joined Cisco from Symantec Corporation about 3.5 years ago or so, where he held senior positions in product development and alliances and business development. And Jeff, we really appreciate you flying in. I asked Jeff if he had hobbies. He said he used to have hobbies, now he has children. So I'm sure between a job with Cisco and children, there's not much time for anything else. So help me welcome Jeff to come and talk to us.
All right, so I'm a quick logistics because I told Ed I want to use my own laptop because I'm actually going to show you some of the products that we're developing and creating. So as he plugs this in and I plug that in, let me give you a quick background. So look, I'm really excited to be here. We're starting to do more and more actually with Georgia Tech in this space and working with folks like Russ and Nick Feimster and are putting more things in motion there. So it's a great opportunity for me to come on campus and see you folks. I'm going to spend, it's kind of hard when this topic, there's a typical audiences I talk to are kind of, they've forgotten more about networking than I know probably. They've been networkers for 20 years. I think we've got a pretty good mix here. So I'm going to do, it's kind of a software-defined networking 101. And mix in a little bit of update and actually show you some of the things that we're doing internally in terms of our own R&D in this space. We have folks that are spending a lot of time coding as well, and so give you a sense of that, and then definitely take some questions at the end. So that's kind of the idea. And part of the reason why I love this topic is that I think networking is undergoing one of the biggest transformations we've seen probably since the Convergence IP. Software-defined networking is ushering a new, really way to architect networks that is going to profoundly change the speed of which we can drive innovation and value from the network out into the environment. And it's funny because I was running one of our big switching business units before, and had been I saw this opportunity in terms of how we could really change the architecture, and it's kind of agitating my boss who runs $16 billion business at Cisco that, hey, we got to invest much more heavily here than we are currently. This is about a year ago, and so he basically said, put your money where your mouth is, go off and do that. So I went from having a 700-person organization to a 3-person organization to kind of figure out what do we need to do in this space, how do we rethink actually how we build products, the environment that we have, the development platform that we use, et cetera. And so, the good news is we're right at the cusp of, we're starting, we call early field trials for the product that we're launching. And really I think it's kind of the initial stages of really seeing what SDN can do broadly for the networking industry. So, I don't know, how many folks have heard of software-defined networking? Curious? All right, awesome. Okay, so so that's good. So I don't have to go too much on the definition. I'll talk more about kind of what I actually really think it means. But there's a ton of buzz in software-defined networking. I really think the seminal event for Cisco was when VMware acquired a company called Nicira, and our market cap dropped by somewhere almost $2 billion in a day. So you can imagine, that got Cisco's juices flowing in terms of what's going on. And the funny thing is, we were already investing in this space, but I think it really started to raise the profile of what SDN can do. And I mean, and it's interesting when you think about, the amount of new ideas and money pouring into the space. It's terrific, and it makes it really fun to work in the space. And we've been very acquisitive in terms of the infrastructure companies that we're purchasing. Insemi Networks that's a spin-in that we've done at Cisco. So a set of Cisco folks went out, have been working on Insemi. We're actually going to announce it tomorrow. So I can't give a lot of details, but it's going to be a really big announcement in terms of kind of what Cisco is doing in this space. And I'll talk to the high-level value propositions as I move forward. But bunch of money, bunch of interest, et cetera. So it's big news. So what's driving it? And it's funny, I think there's a huge, huge tie-in to actually the Internet of Things, stuff that you guys have been talking about earlier today. When you look at how the network operates and the amount of things that are going to be connected to the network, we can't continue to do what we're doing now. It's kind of the short answer. So, the degree of manual administration that it takes to get, devices, users, applications onto the network, just going to fail. And so I think, for one of the kind of guiding principles is the network's going to be a key enabler for the Internet of Things. It's kind of our job is to get those things onto the network. So you can start doing interesting stuff with them. And to do so, we need to really rethink how networks are operated and administered. So, this is just exploding. We had the Internet of Things World Congress, World Forum last week in Barcelona. And the amount of money that, in productivity that we think is going to come out of IoT is going to be staggering. And so there's a huge impetus that we need to make sure that the network is ready for that onslaught of devices. And, in just a very short period of time, you're looking at massive increases in terms of just not only the things that are on the network, but the amount of traffic those are generated. So that's one big driver for why networking as we know it today needs to change. But that's not the only one. There's other kind of key drivers that are coming if you think about it. If you look at what happened with the Nicira acquisition, that was really being driven out of what's happening in the cloud space and these massively scalable data centers. And what we've seen is we've made huge improvements in how a data center is operated with respect to compute and applications. So I can spin up virtual machines and new applications, move those around within a data center, across data centers, et cetera. And the bottleneck we found is that actually the network. So I have all this flexibility on the app side, but there's times when actually getting the network connectivity as I move those applications around is taking, instead of minutes like I can do on the app side, it's taking days, weeks even. So huge opportunity for us to think about that area. And then kind of all of these videos becoming obviously the major traffic going across our infrastructure has big implications on how the network performs, how we want to prioritize different traffic, et cetera. So there are all these kind of new requirements coming on the network. We've gone from, we've gotten users onto the network, gotten devices, kind of done that initial wave. We're hitting a kind of a new inflection point with respect to what's required out of the network. So that's kind of the drivers. Now, there's a problem. Well, actually, let me talk first about kind of these kind of key use cases. So it's actually, we've been looking at this for maybe 3, 4 years, right about actually when I joined Cisco is when this first started happening. what we've seen is there's a number of specific use cases that have kind of popped up. One of the first ones actually came out of academia, so folks like yourselves, and we call it network slicing. And what we saw is that there was increasing interest in. I've got researchers at Georgia Tech. They're working on a project with researchers at University of Indiana. We want to create a segment of the network for those key researchers and all the data that they're sharing to be able to be securely created, distributed, but accessed between those groups. So we call this network slicing. Networks have some ways to do this today, but they're generally cumbersome. And so how can we quickly kind of create these slices, allow the folks access to resources across the network? So that was kind of an initial use case. Then we started seeing the big, really it's the Web 2.0 guys coming at us. And they're kind of interesting because what they have is, generally they don't have that many applications in their data center. They have a few big ones that matter a lot. And what they want the network to behave exactly how they want it to behave to optimize those applications. And what they found is they're just not getting, they're not getting the flexibility out of the networking and the routing protocols to have the traffic move exactly how they want to across their infrastructure. So they were looking for more interesting ways to be able to program the network. And then we started talking to the cloud guys. You think, big, like SPs running big, cloud infrastructures. And their problem was similar, but a little bit different. So they have lots of applications. So instead of the Googles and Facebook, they have a small number of very large apps. They've got lots of applications, lots of tenants, and they really wanted the flexibility. So for them, it was, we're starting to see, the number of VLANs go beyond the limitations in the current standards. So, 4,096 VLANs, we're going past that. You need to give us better flexibility here. We want to move applications and workloads across this infrastructure, kind of, that allows us to optimize them. We need the network to behave that way as well. So that was kind of what's going on in the massively scalable data center space. And then, frankly, in my world, it's kind of the boring campus and branch, but there actually are some really interesting capabilities around SDN for really user access. So we continue to struggle in terms of security and segmentation for users coming on the network. So how can we make that easier and simpler so that I'm Jeff, I'm in engineering, I get access to these resources. If I move to sales, that policy goes, my policy changes, I can get access to the appropriate resources for sales. How can I do that scalably en masse? And we have companies that have contractors and guests and customers and all these different groups hitting the network. How can we make sure that they are getting the right access to the right things? So it's really a kind of a security segmentation piece. That's one of the big opportunities in the campus and branch space. And then, lastly, the enterprise data center is kind of the baby brother of the cloud piece, where I think they were seeing a lot of the same challenges in terms of I've virtualized my compute infrastructure. I need more flexibility across the data center from a networking perspective. So those are the beauty of this is that there are a lot of opportunities for really making the network more responsive to the critical needs of the different use cases, almost depending on whatever hat you're wearing across the infrastructure. So that was, we're seeing these as the drivers that companies were coming at us and say, help us solve this, help us solve this, help us solve this. So, why were they asking for us to help us solve that? Well, it's funny because, I guess I'm being broadcast, so I shouldn't say this, but I will anyways. I think, Cisco caused part of this problem. If you think about how the network evolved, so, kind of early on, networking is very interesting. It's a basically fully distributed infrastructure. So I'll talk about control plane and data plane. Kind of think of the brains and the muscles of a networking element. And what we did is, we put the control in the data plane in a single box. And that's actually some great principles to that type of design. It's kind of fully decentralized. One, it scales perfectly. So add another networking element. There's no choke point really. I get more capacity on the network. Things are working well. Secondly, it's highly, highly resilient. there's no place that if it goes down, the network goes down, generally speaking. So, and there's been a lot of work in terms of how you design networks, make sure you have pretty resilient infrastructure. But it's really made networks scale very well and be very resilient. I mean, you think about just the internet backbone. It's pretty amazing, like how well that system works, particularly when Obamacare is, we have lots of problems as a vendor in IT in terms of making stuff that doesn't work. I mean, the networks works pretty damn well. So that's been those are like great capabilities that kind of came just with how we built networks, and I can take absolutely no credit for that. It was work that's been done, for decades. But what happened was when you do that, we started seeing complexity come into the system. And I'll pick on ourselves. In fact, I'll pick on my previous job. So previous job, I was running access switching. We ship millions of access switches every year. They're what you plug APs and your phones and laptops into, et cetera. And we had Catalyst 2K, Catalyst 3K, Catalyst 4K. Each one of those generally had different functions, capabilities. We created different commands to do the same thing on basically similar boxes. So if you want to turn on quality of service, you've got one command for the 3K, you've got a different command for the 4K, and as Cisco, we have 20 product families across routing and switching, basically each with their own capabilities there. And so what happened was over time you see this complexity introduces into the system where everything, we're doing everything first, we're doing box by box, or potentially even port by port. So if I want to turn on quality of service, I'm going to go to the interface I want to turn quality of service on this box, and then I've got to the one over here and the one over here, and I'm doing that from point to point. And so that's not a big deal if you've got a little network, but as networks have scaled and you move from tens to hundreds to thousands to, we have many of our enterprise customers have tens of thousands, and our SPs have hundreds of thousands of devices, complexity reigns. And what happens is that we have all this functionality and network infrastructure that can't be used, frankly, because the pain that we force customers through actually using it by having to go box by box by box and know that, all right, that's a Cat 4K line card and quality of service is done this way, and that's a 3K and it's done that way, and the router is done this other way, breaks down. And so this is kind of when I look at a lot of the pain points that have been driven into networking and that are forcing those opportunities that we talked about earlier, it's because we've basically created a system that's so complex that customers can't get what they need out of the network. Now, there's some other interesting things about software-defined networking that I find very attractive as well. You think about, when I'm shipping a solution where all the kind of capabilities in that one system, first I've got to develop on an embedded iOS. We have iOS, we call it. Actually, I don't know what the I stands for. I've been at Cisco 3.5 years. I should know this. But we have this embedded OS system. Frankly, let's just say it's not the most modern development platform. I'll just leave it at that. So we release those, we can't release those very often because your network is running on that piece. So we got to make sure that thing is rock solid. So maybe we're shipping it every 9 months. And so if I have a new capability that I want to add, I've got to build it into that embedded OS. I've got to wait for that qualification cycle to happen. Then I give it to the customer. They're going to have to qualify that new release. I talked to some of our big customers. That can cost them $1 million simply to qualify a version of our operating system because they've got every one of our boxes. They've got to test it across all these scenarios. And, hence 2 years later, you may ask me for a capability. 2 years later, I might be able to get it to you. This is ability when I'll talk about now when we're to be smarter about what do we do where in the network, and really kind of one of the fundamental principles of what we're doing with SDN is adding in, frankly, it's another tier in the architecture. and I can be smart about what I want to put on these network elements and what functionality I want to put in another tier. And I can potentially rev that tier much more frequently. I can develop on a nice new, modern operating system, et cetera. So that's the real opportunity in terms of, frankly, from a build perspective as well. So that's kind of that sets the stage for a lot of demand from customers, from networks being more agile, more responsive to what we need. But we have a kind of the current way that we do things is not allowing us to get there. So really enter SDN. And it's not rocket science in terms of what we need to do here, I don't think. I think there's an opportunity for us to radically simplify how networks are operated, deployed, and really built over time. And so that's kind of the capability. And I think there's this beginning to be a seed change in the industry around. We've delivered more and more functionality. We're seeing that it's difficult for even some of our most sophisticated customers to consume that. So how do we kind of change the paradigm and provide them networks that do what customers need, but in much more simple, agile method? We can't lose the resiliency like we do. The network has to stay up, but let's make sure we do this in a better way. So that's kind of the driving principle behind what we're trying to accomplish with SDN. So let me get into a little geek out here for just a little bit, because if you're in the industry, SDN can mean a lot of things. It's funny. So there's the Open Networking Forum. It's kind of it's a set of customers actually and actually researchers that coalesced a few years ago, and they've really been helping to drive the SDN across the industry. They had a forum last spring out in Santa Clara. And it was really funny because at the forum, you'd go and there'd be folks like me, keynotes that come up in front of the whole audience, and they'd talk about SDN and kind of define SDN, and they all disagreed with one another. Like you'd actually have them come up, one keynote speaker would come up on stage after the other one and say, yeah, don't listen to that last guy, he was wrong. This is what SDN means. So I'm not a purist just in general, so I'm going to talk about, there's lots of different kind of, types or different ways that people kind of categorize under SDN. So let me kind of talk about those just to give you a sense, because I think all of these are actually valuable in terms of solving the problem. And I don't think there's a single one way that's the right way. And what you see is across the industry, there's huge investment in multiple different areas that I think combined will help us solve what we need to do. So today's model, I talked about the box. Think of that as a router or a switch. Control plane and data plane are together. We talk via, and this is part of the problem, we talk via CLI, SNMP, other ways to that device. That's error prone. CLIs are all different. It's basically slowed us down. So one of the first things you're hearing about in the industry is this idea around, well, let's make a much better, more programmable interface between the things above the network element and the network element itself. I view this as just an enabler to SDN. It's not really SDN at all, but it makes the lives of everybody that's trying to work with the network elements a lot better. Because, for example, at Cisco, we're creating what we call 1PK. The idea is that we go away from the CLI commands being different across every box to having a single command to do something. So it makes sense. It's kind of motherhood and apple pie, step in the right direction, kind of necessary but insufficient. So next, there are the kind of what I think is more kind of classic SDN. So the first one is, I just call it pure SDN. So Nick McEwen, is a researcher at Stanford. He's kind of the high priest of this camp, I would say. He was one of the guys that came up at Open Networking Summit and said that, look, be straight. SDN is only when you physically separate the control plane from the data plane. So the idea behind kind of this model is the control plane, think of kind of the brains of the switch, is moved off the switch or the router to a central location. So a good analogy I like to use is think about like all the traffic lights in Manhattan. Today they're all local, right? So you've got local sensors, traffic lights are on some program. They generally make decisions in terms of, red, yellow, green kind of independently. This model would say, I'm going to control all of when they're going red, yellow, and green. I'm going to like have a central like brain that programs all of that. That's kind of the way to think about it. So the beauty of this is, you got to pull that entire control plane out. With it comes the need for us to change to create basically a new protocol to talk from that control plane to that physical element. So there's a bunch of efforts there going on in the different standards bodies around that. The good news here is you get full centralization. The bad news is you may have some issues with resiliency. You kind of lost that model whereby you've got a fully distributed network. So, there may be a scale issue on the controller, like how big a network can a single controller do. There may be issues with respect to resiliency. That's all the stuff that's being worked out. Like there's a ton of research being done just in these areas. That's kind of the model that, of kind of 2A, kind of pure SDN, rip the whole thing out. Now there's a kind of a hybrid approach to this as well, and that would say, if I don't want to control all the traffic lights in Manhattan at all times, but sometimes there's a parade, sometimes there's a traffic accident, so I want to at least be able to kind of override what's going on in the kind of the decentralized mode to do certain things. So that's kind of the way I think about this hybrid SDN. The idea is let's kind of think about having some ways to kind of override what's going on, but maybe not do that as a default. So you don't get the same degree of centralization, but you get this ability to kind of at times be more determinist, or you kind of control how the network is functioning more specifically. Personally, I think this is actually a very good approach. It's kind of it preserves what works well about networks, but adds some of the capabilities that we've been lacking. And we start being able to make interesting decisions in terms of what control plane functions do we want to reside still on the box and what do we want to pull out. So for example, if you think about that campus use case around security, I think that's something that makes sense to be centralized. Like we should pull that type of capability up off the box, centralize it, while still maybe using the kind of the existing infrastructure around L2 and L3 control planes and distribute that. So that's kind of the idea between how we're looking at this. So that's this model. Now there's another model that's actually very interesting as well. So this is overlay network. And if I were to pitch you why overlay network makes sense, what I would say is take the network as it is today. Don't change it. You give me physical connectivity between all the devices. I'm going to virtualize on top of that. So I'm going to then basically do, think of, it's kind of similar. We're doing this, VMware is doing this. The pitch is just like we've done on servers, let's virtualize a network. And so I'm going to give you via software, I can change segmentation, do funny, interesting things across the network. I can do that in software. It's very quick, happens great, have at it. So highly flexible. You can use it on the existing infrastructure. It kind of particularly helps solve this. Initially, is being used in that big, massively scalable data center and the kind of large data center environment. So I can move virtual machines around. I want to be able to move the network around as well. So the one potential concern about this method is that overlay doesn't have visibility into the physical network. So there's a lot of work being done on how can a virtual network also know what's going on in the physical network. Because let's say, unfortunately, links still go down. If I'm completely virtual, I've got no visibility to that. And so my network will stop working, but the virtual network will think everything's healthy. So there's a ton of work being done in terms of how do you basically create, we kind of call integrated overlays. So you kind of get visibility in the physical, but you got all the flexibility on the software side. And frankly, what we're going to announce tomorrow within SIMI is going to be focused in just this area. So that's kind of the idea around that. So I'm going to stop geeking out, but this is some of the kind of more down in the weeds functions and capabilities of what's going on from an SDN perspective. It's early. There's a huge amount of investment here. I think we are years away from really understanding what are the ones that are going to be most valuable across the infrastructure. But it's a great time to be in research. It's a great time to actually be in the vendor side because there's so many opportunities for us to go after. So, when I'm looking at what I think the answer is going to be, it's going to be something where we preserve what works well, but we add the ability to be agile, simple, and application aware. So I think that's again, I don't have the complete answer here, but that's where I think we need to go. And how this is going to work, kind of what we envision is, assuming the network's operating, chugging along. What we need to do is we need to understand what's going on in the network better than we do today. So think about this idea around pulling all the information about how the network is operating, what's working well, what's not, where traffic is, where users are connected, what applications are flowing, et cetera, and bringing that information off the network. And once we have that information, we start doing really interesting things around analytics on it. And this is, I think, one of the key things that's going to happen with SDN is the networks, particularly when you think about Internet of Things, they're going to be so big, there's no way a human mind can keep it all straight. So we need to use big data analytics, machine learning, et cetera, to make networks operate better. Kind of humans still need it. We need to be able to understand what policies are critical. What applications you want to make sure the network is run best. But we need to then allow kind of, frankly, software to be able to then define how, based on those policies, that intent, how do we want the network to operate to ensure that's going to happen? And we think the way that's going to happen, that's got to be through big data and analytics. And the beauty is, it's kind of frightening how little we use this today, but we're sitting on a treasure trove of information. And so I think there's a huge amount of opportunity for us to work in analytics in this space, think about how the network can get predictive, and really change how operations happen. So I think there's a big opportunity, for folks who are looking for things to work on. This is one area that we'd love to see more and more research on. And then, so what would happen is I'm doing this in intelligence. Once I understand what's going on, I can then basically orchestrate the network to behave better. So a good use case is, let's say my PC is infected, and I plug in the network's kind of monitoring my traffic, and it sees that there's an anomaly in terms of how my machine's behaving. A great thing to do then would be, with that analytics, we can then go and say, hey, network, we want to quarantine Jeff. And quarantine could mean shut me out. It could mean let me get out to the web, but that's it, no internal resources. There's different things, or it could mean, I just want to take Jeff's traffic. I've got some data scrubbers in the data center. I'm going to fork his traffic off specifically, put him through these deep packet inspection, and kind of really understand what's going on. But you think about, there's a way, and then the idea here is that with that policy, with that intent, when the network then is programmed to do just that. So I'm an access switch. From there, I'm going to, the network's going to say, all right, I'm going to take Jeff's flows. I'm going to do basically a custom forwarding to, this part of the network where I've got my deep packet inspection engines, and we're going to do that. And that's something that, today, to do this, someone would get an alert. Oh, crap, I got to go, hop onto a machine, basically fork Jeff's trap, put him in potentially a VLAN that I've already had to create that allows him to, that puts him over on this part of the network, but it's manual process. There's no way that is how we need networks can't operate that way long term. So that's the idea is this kind of combination of analytics, policy, and orchestration to allow the network to become dynamic and intelligent. So that's where we need to go. So that's really, when you think about our model, that's how we want to evolve. It's this idea around, I never want customers to worry about an individual box. They should care about the network. It's a big paradigm shift for us. We want to move from this idea from human intelligence to automation. We think there's great benefits from a operational capability, efficiency, et cetera. And the last thing is, I think this also becomes a really interesting, SDN was going to hopefully usher in a new world of applications on top of the network. Today, if you're creating a enterprise application like SAP, if you want to get something out of the network, you actually got to go and plumb to each of the individual network devices. So it never happens. Basically impossible. Think of in the future, the idea was that SAP would say, hey, maybe it's into the quarter, and I'm going to need higher priority resources from the network. Basically the application or the application team could go to the network and basically ask for higher priority, more bandwidth, et cetera, for this application, potentially just for a period of time, and the network can give that to them. And so there's this opportunity for us to really make the network more reactive to what higher level applications need across the enterprise. So this is just how we think about, we see it working. So you have the network elements as you do today, put a nice API on. And then the idea we're going to see is to insert this control layer. This is really where the magic happens. The idea is this controller becomes a place where I basically abstract all the underlying elements. I provide northbound from this controller an API for applications, monitoring, et cetera. But really the controller becomes the place you go to the network. The funny thing is we kind of do this today if you're familiar with wireless. People don't talk to all the individual APs. They go to a wireless LAN controller. The whole idea is it's a very similar paradigm in terms of what we're trying to do. So that's the idea. And you go to that controller, right, you can ask it about what the network looks like, how it's performing, how do I prioritize certain applications. That's the beauty of where we're going from an SDN architectural perspective. And then on top of that, this ability, I think this ecosystem can explode in terms of how we build on top of the network once we do that. So one really interesting thing that's happening as part of this whole process is the kind of the new standards and openness that are coming as part of this activity. So this control layer, I think this is like the key to making SDN work. So what's being created is actually an open networking, Open Daylight, which is an open source consortium to create this layer across networking. So the idea is that there's lots of different networking elements down below. So we need to create basically an open kind of middleware that anyone that builds a networking device can plug into from the bottom, that anyone can contribute in terms of the development of, and that it can be basically consumed and widely proliferated due to the fact that it's open and open source. And so the idea is this Open Daylight project is being kicked off. There's a bunch of vendors, Cisco, basically all the kind of big networking vendors are participating in this project. It is essentially the way I think about it. It's like the Linux kernel for the controller. We're going to take that kernel, we're going to wrap some additional capabilities into it and ship it as our SDN controller, and anyone else can do that as well. So we're seeing a huge groundswell of investment just kind of across the open source community. It's being driven by the Linux Foundation. They're overseeing the work. So it's really kind of ushering a new, kind of, I say, almost methodology for development and networking. We've always been pretty good at standards. I guess, one thing that networking has been pretty good at in terms of how we work in the standards bodies and creating standards. This is kind of a new, kind of taking that to the next step. So I think it's one of the interesting things about how SDN is kind of changing how the industry itself operates. So real quick, let me get kind of out of the theoretical and talk about how would this actually potentially work. So think about today, we've got routers. So if you're in any, there are routers that connect this campus to the internet, and I don't know exactly how the core of your network are, but there's lots of routers out there that basically are the connectivity between branches back to the kind of major corporation. So today, most of those branches today have two links. So you'll have a couple links across your infrastructure, but generally there's a primary link where you send most of the data. Today, setting up these darn routers is pretty hard. Lots of CLI commands, lots of manual effort, et cetera. So the first thing you could look to do is basically have a controller and a capability on that. So I plug a router into the network. The controller discovers that router, says, oh, this is where you are. You're going to be connected to this head-end router. This is the image, the OS image you're going to use. This is the configuration template that's going to be part of your infrastructure, et cetera. Push that out, plug and play, make it work. So, it's funny, this isn't a big leap from a networking perspective, but it's hugely valuable for our customers because today there's a lot of manual effort and frankly then errors that are introduced as part of this process. What's more interesting is thinking about how we're actually being smarter about how we route traffic. So assume that this is the infrastructure you have and your primary link starts to slow down. The controller's monitoring that network at all times. It sees that it's going slowly, so then actually will go and update the routing to move that traffic from the primary link to the secondary link. And again, kind of simple, but incredibly valuable for customers. And then you can think we can augment this. So instead of just doing performance as the variable to move traffic around, we can introduce things like how much does a link cost? So I can use cost-based routing and can call it routing for dollars. I can use security. So there's certain links I can only use for certain types of traffic, et cetera. So there's a whole ability for us to become smarter and smarter about how we're moving traffic around the network. And I can do this, again, instead of in the old days, if I wanted to change this, I'd have to update iOS here, have to update iOS there, have to build it, ship it out. 2 years later, maybe you can do it. In this case, we did a routing for dollars app in about 3 weeks. You put that app on the controller, you're ready to rock and roll. So that's the beauty of the way that we can build networks really changes as part of this. So let me just real briefly kind of show you kind of this in action. So this is what we're building. This is actually a 3-month-old code. We're like 2 weeks early for me to show you the real beta version that we're shipping out. So it's going into about 8 customers' hands in the next 2 weeks. But this will give you a sense for what's happened. And the beauty of this, so this was 10 people in 10 weeks. So maybe a little bit more than the effort that the teams did for the contest, but it's amazing how much can be done in a relatively short period of time building on a modern infrastructure. So this is a network that we've discovered. We have a mix of kind of classic Cisco devices and OpenFlow devices. One of the key things about this principle is that the controller becomes the state of truth for the network. So the controller kind of knows everything that's going on, has the full running configs of all the boxes. This is the running config on whatever box I clicked on. And that becomes a really interesting thing for us to use and parse and do analytics on. And I'll show you some of the things we've done with that in a couple of the apps here. So all this is a database. Database with all the information about the network on top of it. We can take that. We can do very like basic things around like topology and stuff. And again, the beauty of this app is this is JavaScript. The controller is REST northbound APIs. So we're doing JSON and JavaScript to basically render this UI. All the APIs are open. So any customer, ISV, et cetera, has access to those REST APIs as well, can go out and build whatever they want to on top of this infrastructure. So it's kind of this idea of really making it easy for them to do that. You can do kind of smart things here, and you guys aren't really switching people, but for me to type, I can type in router and it finds the routers in this infrastructure. It's stunning. You'd be surprised at how impressed our customers are that we can do simple stuff like that. Like we put them through enough pain that it's just little things get them very excited. So because all I'm doing is searching the database for information. I can look for IP address ranges, find all the devices in those IP address ranges. I can look for specific products, 2960, it's up and going. But again, super simple. So that's just the basic. Now, I can take that, and you notice I'm using the same topology service that I built there for this application. And this is around access control. So one of the big pain points we have is, let's say I want to put a new application on the network. I want, me, Jeff, to get access to, across a telepresence unit between 2 endpoints. Is that going to be allowed or not? And it's actually very difficult for our customers to understand this today. So we built a little app. What we're doing is we're sucking in all of the access control list functionality from the infrastructure. And what I can do is I can do a trace across the network for a certain application type. And what this will do is figure out what path would that application take across the network. It will determine whether or not that application will be enabled or not, and it'll show me all the relevant ACLs that would be, be part of that flow. So the beauty of this is it allows you kind of a what-if analysis for customers to see that they basically haven't been able to get access to before. So this is kind of all the ACLs that would potentially block traffic from going from one place to another. So nice, kind of a step forward, but even better would be what we're doing on quality of service. So the idea here is, let me disable this. Right now, again, we talk about quality of service. That is, how important does the network treat a specific application's traffic? So today, for us to do this, we've got to go device by device across the network. We've got to configure QoS in each one of those devices. All the CLL commands are different, et cetera. What we're doing here is we've got 2 access switches here. We've got 3 clients attached to each one. 2 of those clients are sending basically noise traffic. The third one's sending video. Red shows that we're dropping that video traffic. And so all we're going to do is click on Enable Easy QoS, and the controller understands each of those devices, what iOS version they're running, what their role in the network is. So are they an access switch? Are they a distribution switch? Are they a router? We're taking the best practices. So Cisco has spent tens of millions of dollars figuring out best practices for configuring quality of service across the network. And we're automating and deploying that all in one fell swoop. So you think about, in the version that's going to come out in about 2 weeks, you'll be able to drag and drop which applications you want in which tier. And the network will take your intent, and then basically apply that policy across the entire network infrastructure. So it's this whole idea of we should think about the network as a system. And you basically care about what applications are running, how important are each of those applications, what users are allowed on, and what resources those users can get to. And that's 80% of what you need the network to do. And we've just made it, frankly, too hard for customers to get that value out of the network. So this is the paradigm that we're driving to in terms of changing that. So again, it's fun. It's early days. I've got 20 guys doing this. But basically, it's the idea is you build this platform, and then on top of us can be all these ISVs and other partners that can build capabilities on top of this infrastructure. So that's kind of the idea. Oh, hold on. I went too far. All right, so it's a couple more slides. So this is really, this is changing how networks are being built. So a couple kind of things as I've been looking at what's going to go on and how things are going to change. So one is, I think standards are going to remain critical. It's been kind of a long history of networking. I think there are new standards being created. They're going to be important. We're looking at, ONF is driving OpenFlow. But I think you're not going to see a big change in that. If anything, standards become more important moving forward. We are seeing this move to open source. We've open sourced our controller that became the core of Open Daylight. Juniper followed suit and open sourced their controller. You never saw this in networking previously. So I think it's really interesting how that's changing and how we're getting kind of the broader community investing in kind of these core networking plumbing. It's really going to help, I think, accelerate our ability to get value and capabilities into the hands of customers. So lots of work there. OpenStack's another big area of open source that's being invested in very heavily in this space around orchestration across the data center. I think you're also seeing increasing openness. We had CLIs that were kind of open, but you're looking at us and HP and all these vendors who are creating big developer programs. That we're opening up all of the APIs from our network elements and from our controllers, allowing people to develop on them. So I think there's a real interesting opportunity, for third parties to look at, all right, how can I kind of build on top of the infrastructure and add interesting new capabilities to that. And then lastly, I think there's been a lot of talk about, well, is this going to commoditize networking? I don't see it at all. I think the announcement that we'll do tomorrow, there's some really interesting stuff we're actually still doing in hardware. Now, if you think about there may be different things you do in software and hardware, but I think there's still going to be real value in the network, the optics, in the chips, in the actual network equipment itself. And the interesting thing is even now today, if you look at Cisco, so the group I'm part of our engineers, probably 2,500 of the 3,100 engineers are software folks. So we're already, software is already the dominant piece. It maybe becomes 28 out of 32, but there's still opportunities to continue to really innovate in both. So it becomes a big and interesting opportunity. But what I do think it does is it creates a lot more ability for folks to do interesting software things above our stack. So that's, I think, going to be the big new delta that's coming along. So this is just a small list of companies that were already building on basically our immature standards. I've got a line of companies out my door that want to come and build on this. So this is where I think what happens is that more and more companies can harness what we're doing in the infrastructure and take advantage of it. And then lastly, last thing, it's early. That's my close. But when we look at how customers are going to do this, I think it's going to be a journey. This is a very different way to operate networks than we have today. And so what I see is kind of the first step I talked about was read-only applications. So think about that trace route that we did. Like that's an easy way customers can kind of dip their toes. We don't do anything to the network, so we're not going to break anything, but it allows them to kind of get value out of the network. So that's a good kind of initial step for folks to take. The second probably comes in around kind of that base getting the network provision, automating kind of the menial tasks around configuration, et cetera. That's kind of low-hanging fruit. I think good opportunity to do interesting things. Then moving on, we start getting into some more kind of interesting things. And I look at network services as being, all right, we'll start doing some smart things about, moving paths around and moving traffic around. We can inject custom encryption. So we're actually making changes to the network. We're kind of doing those as a kind of one-time event. So there's still an operator that says yes to, make the change in the network. And then kind of once we've kind of proven out the ability to do that with quality and stability, then I think you start seeing the creation of the dynamic network, where the network's actually going to be, doing, intelligent things roughly on its own, and really kind of looking at how do we change the network, based on what's actually happening in the network. And so that's kind of really the last piece. And at that point, then you can see, the SAPs and the Oracles, et cetera, kind of programming directly the network and getting out what they need. So that's roughly how I kind of see the whole thing evolving over the next, say, 5 years or so. It's going to take a while. So that's kind of where things are at. It's early. This is one of the things where I feel like if you guys are familiar with the Gartner hype cycle, we are like right at the top of the Gartner hype cycle. There's going to be, we're going to head down into the trough of disillusionment when people, this didn't do everything I thought it was going to do, et cetera. But like, hang in there. Like, I really do believe, in a few years, networking will be done fundamentally different than it's done today. And it's going to open up a whole new set of opportunities for folks, kind of around the network to do even more interesting things on top of it. So with that, I'm done.
And would you be willing to take questions outside of SDN if you're?
Absolutely.
All right.
I can always say no. So
you can always say no. All right. Questions?
Where does Star OS fit in your roadmap for 1K?
Star OS. The old?
No.
EPC.
Mobility.
Yeah. So we're going. It is there. I don't know the date at which it would be coming out. Kind of more the SP guys, but so the start stuff. So we're looking at every OS has that the 1PK API set coming on top of it. I think it's going to take time. What I see is, even on our platforms, I'm prioritizing stuff I can't do via CLI today first via 1PK. So things like traffic manipulation, and then I'm going to go hit the stuff that's done by CLI. So it's probably a 2-year journey for us to kind of get it broadly adopted across all the pieces. But I'll take that. Give me your contact information. I can find out more details. I'll go harass the operating system guys and come back. Okay, got it. Perfect. Ross.
So first, congratulations. Early on in your slides, or in your presentation, you mentioned, you confessed that Cisco may have been part of the problem. That's the first step to recovery, so
Thank you, Russ.
Yes.
I appreciate it.
Seriously, so this notion of complexity.
Yeah.
And one of the goals of SDN for some folks is removing complexity. Ron likes to say that complexity is preserved. You don't actually ever get rid of it, you just move it around.
Hide it.
In this case, what I'm feeling as I looked at column 4 and the virtualization is, in fact, complexity is being thrown in a room and allowed to multiply without end, right? We're basically in a situation today already, and I'm concerned we're going even further down the road of it's impossible for one person to understand what's going on and solve a problem, right? Debugging is a mess. And so while I really like the visualization of the trace route, et cetera, and show me what all the ACLs combined are doing, one of the challenges we have is what if one of those devices is not behaving according to the model, right?
Yeah.
So on campus this week, we had a firewall that misbehaved. No tool was able to model that behavior. It was a bug, right?
Yeah.
And so, how do we dig through that complexity so that we can debug these problems? We can do the troubleshooting it's going to take, because in fact, with virtualization and all these layers, it's getting more complex.
Yeah, and I think this is one where the analytics become a necessity to get there. If you had the proper analytics, you should be able to say, well, this is something's out of the norm, and allow us to at least pinpoint more quickly what's going on out of the norm than we can today, where it's really, frankly, very, very difficult at times. So I do believe if we have better instrumentation of the underlying network infrastructure, we feed that into things that you can see things that at least I, as Jeff couldn't figure out. I think it becomes an opportunity for us to get there more quickly. But I really do think it comes down to instrumentation. You look at what we'll announce tomorrow. We've spent a ton of time trying to just be smarter and smarter about what we can expose from an instrumentation perspective, because we know that humans can't keep up. There's just too many things. But we've been poor, frankly. It's been hard. I mean, a lot of our devices aren't well instrumented today. So it's kind of we create blind spots for customers.
So this is not the first attempt to separate the control plane from the data plane?
Yeah, I know.
So some of the historical reasons for that often has to do with the cost of the software to do the control plane. And so I'm curious, my question is about, since I'll piggyback on Russ's comment, you set the stage by saying that Cisco helped create the problem.
I'll get in trouble.
Yeah.
Exactly.
Yeah, right.
Get that off the internet.
Yeah, right. Yeah. So obviously you have lots of customers that have lots of your equipment that has both the data plane and the control plane in the same box.
Yep.
And that means there's lots of control plane out there that costs money that in many cases isn't always needed in every box. And so I'm curious from the customers, your presentation had a lot to do with the benefits of SDN as it relates to programmability, flexibility, innovation, new services.
Yeah.
But one of the other pressures out there is cost.
Mm-hmm.
And so I'm curious about what your customers are telling you about those two benefits. The programmability, flexibility part versus we don't need a big control plane in every box.
Yeah.
Sometimes we only need a little control plane. Sometimes we need no control plane.
Yep.
Is it a 50-50 mix you're hearing from customers? Is it
Yeah,
weighted one way or the other?
It's weighted far more on the simplicity and services piece, but frankly, it depends by who that customer segment is. You look at the big, MSDC players where this is a big part of their COGS. They'll have more focus on the cost piece. Versus if I go talk to an enterprise customer, it's like, look, I really need. We're doing a joint venture. I want to make sure that we are, have a good segmentation across the infrastructure. And networking as a cost of my overall business is a small portion. So I think I see a high correlation to the amount of which network creates of the overall COGS of a service or offering, and the degree of focus on cost versus services enablement.
Two questions.
Shoot.
The first one is with regard to things like the Easy QoS or the Easy ACL that you're designing in
Yeah.
that app. Are you doing that actually by exposing a QoS API from the boxes to the system, or is that sort of phase two, and this is really, you've got a catalog of all the devices and you know how to issue the commands to them?
Yeah, so it's more the latter.
Yeah.
Yeah, because one of the focuses that we had was, we have a lot of customers. We have a huge install base, and even getting those folks
With
to
old
up-
stuff.
What?
With old stuff.
With old stuff, yeah. And so, one of the opportunities for us is to bring SDN value to those existing infrastructure. And to do that, frankly, by talking CLI to those boxes, but hiding that complexity at the control layer. So I don't want them to have the focus on, they don't have to remember how many queues are on a line card or what DSCP value to program. They just tell me what are the applications that are highest priority, and we translate that intent into the actual CLI commands to those infrastructure.
Okay.
Great question.
Okay, thanks. And then the second question is, just how far down the stack can software definition go without actually spinning new silicon? The example that comes to mind would be something like, because the original purpose of SDN, and I'm sure there are 10 other definitions as well, but the original one seemed to me, hey, we want to experiment with making completely new things.
Sure.
So if I want to do something like super jumbo frames,
Yeah.
how do I do that? How do I do that?
To do that. Yeah. So, we're trying to figure that out ourselves.
Okay.
And
I try to ask hard questions.
What?
I try to ask the hard questions.
Yeah. No. So, I think there's a lot of limitations. We look at OpenFlow. There's a huge amount of limitations in terms of a lot of the current ASICs to be able to do that at any meaningful performance. And you kind of got to do meaningful performance for it to be valuable at scale for our customers. Right. There are some capabilities. So we actually introduced an ASIC about 9 months ago that has a little flexible parser, fully flexible data pipeline that we can basically reprogram so that we can do much better from a performance perspective with OpenFlow. Multi-table support, we're still trying to figure out, can we do that with that existing silicon, or do you need to respin it or not? And so there's work to be done just there. So I think there's generally, most ASICs you'll need to actually redo silicon to get true flexibility in those areas you're talking about. Or you have to throw an FPGA on, or there's other ways to kind of get around doing some of that, but it's hard given at scale, like you're looking at 40 gig throughput.
Yeah. It'll be new and it won't be cheap. Got it. It might be cheaper.
Look, ASICs aren't a huge part of the cost infrastructure anymore, anyways. So, it won't make a big impact onto the system cost. Would be the option.
All right. Thanks very much.
No, perfect.
Jeff, I have one question.
Sure.
This is a research university.
Yeah.
One of my fears has been that industry has jumped on SDN so quickly that it's going to stifle the research that could take us much further.
Yeah.
And as you implement, it costs you money to burn silicon, to do all these things, write software.
Yeah.
Are we jumping too fast on this? Are we still able to move the research forward and not stifle it by having the install base so big like it is today that we can't move?
Yeah, well, I think there's maybe two different issues there. The install base problem, it's just there. And I don't think there's anything, it's there. Just because it's there doesn't mean we shouldn't be doing research against it. And will that potentially delay the implementation of some of these capabilities? Yeah, but I think that's going to happen anyways. Install base makes my life harder too. But we shouldn't let that stop us. I do think we need to just be careful of overhyping.
Too late.
Yeah, it's already too late. So I think it's hard, and we just need to. And that's part of the conversations. I can't remember. I was talking to one of the founding members. The head of network architecture at one of the companies that was a founding member of ONF, and he's like disappointed with OpenFlow, and because right now it can't do everything you need it to do. I think there's still a ton of research that should happen Yeah, and that's why I think we're going to head down to the trough of disillusionment. That shouldn't stop us from all of the actual research that's going in, because I think that the benefits that we can deliver long term will be hugely impactful. So just keep strong.
All right. Well, let's thank Jeff. Jeff, thanks so much for coming
thanks, everybody.
to visit with us.
Ron?
Yes.
So I had one more question for Jeff.
Oh, I'm sorry.
I stole my mic. So Jeff, fair warning, I asked this of Ralph De La Vega last year, and it got exciting.
You asked who? Sorry.
Ralph De La Vega this question last year.
Okay, all right.
So the question is, can you speak to your expectations of Georgia Tech? What do you want from our research community, these students? What can we do?
Yeah, so we're actually talking to some of your guys. But I think I see a couple places. One is, I think there's just some of this core fundamental research is really interesting. And, places that we're looking at, security implications of this, there's a bunch of work in terms of like kind of the idea around policy and intent and how do you, what language should we use? How do you find conflicts? There's a whole bunch, I think, just kind of core, how would you actually make this work that are really meaty and interesting, and we'd love to continue. And actually, I want to strengthen the relationship between the teams that do so. And secondly, I think, if you look at the competition you guys did, I want to see innovations on top of the network.
Yep.
And that's, I think, another area that is really going to hopefully become much more exciting, and you can kind of like what's happening. We see in mobile how quickly you can get an app up and running and do valuable stuff. I think there would be an opportunity to have, I think, maybe not quite the same velocity from a network perspective, but a lot closer. And so I'd love to see innovations and ideas on top of what we're doing here as well. So those would be the two things I'd love to partner on. Okay.